Hello again. This is Math 2115 coming to you from the College of DuPage. And the title of this lecture is Low Stakes Assessment 2 and Introductory Comments about Quantifiers. And as always, be an active learner as you watch this video. First, we'll talk a little bit about Low Stakes Assessment 2. I was born in Indiana and have lived a lot of my life in Illinois, and I traveled a lot within the United States, but one of the most broadening things was when I did a consulting project in Bahrain. And you see, this kind of is insulated, and for the most part, people in the United States speak English, and that's kind of what everybody seeks to speak. I realize other people will speak different tongues, but I got by just fine speaking English. When I went to Bahrain, most of the people that I worked with were educated in the United Kingdom. They were very well educated, and they spoke typically 5 languages, including French. But my little story here about Bahrain is it's a different place, because you see, instead of being kind of isolated in the middle of a country and everybody on all sides speaks English, here there were a lot of countries, and so this is a hypothetical thing, but actually it's very close to being real. So in a town in Bahrain, 85% of the people speak Farsi, which really is Persian. 40% speak English, and 20% speak Arabic, which is actually the official language. To hold political office there, you have to speak Arabic. It is also known that 32% in this town speak Farsi and English, 13% speak Farsi and Arabic, and 10% speak English and Arabic. So there are 3 questions that I ask. How many speak exactly 2 languages? How many speak all 3 languages? And is there anyone who speaks none of these languages? This will be posted, and you'll know more about when this is due, but I wanted to just read through it, and this will be due reasonably soon, by the end of next week. Now, the next topic that many of the lectures are going to deal with, and I'm not going to cover it all here, I'm just kind of introducing the topic, is called quantifiers, and there are universal quantifiers and there are existential quantifiers, and this is the introduction to that idea, and more notation follows, and these also end up being propositions. So there are truth values that can be associated with this, and later on we're going to do proofs relative to these as well. So by way of introduction, so we have a symbol that looks like an upside down A, and the way we read this is for every x, or for all x, or you could say for each x, but this means all x. There's another quantifier that looks like a backwards E, and this stands for, the way you would read this is there exists an E, or there exists an x rather, not an E. There exists an x, and that means there's at least one x that satisfies some property that might follow this. Now that in itself isn't difficult, but many of my students find the nested quantifiers, when you have parentheses and things like that, it gets a little bit more involved. You have quantifiers inside of quantifiers. You have negatives that are flying about, and you have to be concerned about domains of discourse. So I guess I'm going to say it's not as easy as it sounds, and I think I have, I don't know, 4 or 5 videos that I'm going to share with you in addition to this one dealing with this topic. So, watch them intently. But let me give you 2 examples. So suppose I say, let C equal all College of DuPage COD students. We then could say, for every C, an element of C, that means that lowercase c is a College of DuPage student, comma, there exists an ID number, I of C. Now, I depends on who you are, because you have a unique identifier that is a positive integer. And a positive integer means these numbers could start with 1 and just 1, 2, and so on and so forth, and keep going. Actually, these tend to be 7-digit numbers, so many of them are quite big. numbers, but for every student there exists this. Now that would be a true statement. Here's another statement though. I could say for every x an element of the integers, and you should know the difference between integers and positive integers. So for every x an element of integers, and that means 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on and so forth, x squared is bigger than x. So this is saying for every integer x squared is bigger than x. Well, that's not true because there are 3 where x squared is equal to x as an example, and the 0, 1, and minus 1. So, while this is false, it is true that there exists an x in z such that x squared is less than or equal to x, and in fact we have 3 of them right here. So you see that can be true and false, and that's pretty much my introduction to this topic. You might wonder, well, how are we doing? We're actually doing just fine. There's 12 chapters in the book. We don't necessarily do all of them. We'll see how many we get done. I do know what I'm supposed to do. I shared that with you in the syllabus. But we finished chapter 1. So as you're working the homework and reading the book and working on the LSAs, that's where you want to be pretty soon. And again, I'm going to be posting an announcement with the things that we're going to be doing next week. We'll at least do this, and we might go beyond this. In closing, for now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. May God bless you all.